Hello everyone, myself P.Jithendar, Department of Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad. So in today's video's lecture, I am going to discuss about the Reciprocity Theorem. Okay, so here in this Reciprocity Theorem, so here we need to discuss about what is the statement of Reciprocity Theorem and what is the procedure. What is the procedure involved in the Reciprocity Theorem, and we'll discuss about the one problem on Reciprocity Theorem. Okay, so here first of all statement. So what is the statement of Reciprocity Theorem? So here the statement of Reciprocity Theorem is, so it states that the Reciprocity Theorem states that in any linear or bilateral network, the circuit having only one independent source, the ratio of the response to excitation is constant even though the source is interchanged. The source is interchanged from the input terminal to the output terminal. That is the statement of Reciprocity Theorem. So here, for example, I am taking one circuit here. So here in the given circuit, so here I am taking one circuit. So we are having the voltage source, let us take as V, and the resistor is R1 and resistor is R2 and resistor is R3. So here in this Reciprocity Theorem, suppose I need to calculate current through R2 resistor, means we have to find out the voltage and current ratio. Okay, let us take, I am taking this as a I1. So in this Reciprocity Theorem, we have to find out the voltage and current ratios. Okay, so here we are already having the voltage source, that is V, and we have to find out the current value. So current is nothing but the current through R2 resistor, that we have to find out. After that, we have to find out the voltage and current ratio, that is V divided by I1. Okay, so this is case 1. Suppose in second case, so in second case, as per the statement of Reciprocity Theorem, we have to interchange the voltage source to the secondary side. So means, so the next circuit is, we have to short circuit the voltage source. So here voltage source is short circuited, and we are having the elements resistors, and here we have to interchange the voltage source. So plus minus, voltage is V, and here the elements are same only, resistor R1 and this is resistor R2 and this is resistor R3. Now we have to, in this second case, so this is case 2, in this second case we have to find out current here. So current through R1 resistor I am taking as I2. Okay, so in this case also we have to find out the voltage and current ratios. So that is V divided by I2. Okay, so in case 1 we have to find out the V divided by I1, that is voltage divided by current I1 value. In case 2 V divided by I2. So voltage source is V divided by current through R1 resistor, that is I2. So after that we have to verify if it is a right or wrong. So how we can verify? So verification. So verification is nothing but, so case 1 solution is equal to the case 2 solution. That means V divided by I1 is equal to V divided by I2. So these two ratios should be equal when source is interchanged from the primary side to secondary side. Hence we can say the Reciprocity Theorem is verified. That is V divided by I1 is equal to V divided by I2. In that case, the Reciprocity Theorem is verified. So this is the calculation part of the Reciprocity Theorem, right? in this reciprocity theorem, we are having some steps here. The steps of the procedure of the reciprocity theorem is, so first here we have to find out the total number of the branches in a given circuit. That is step number 1. Step 1. And step 2 is, so we have to find out the total resistance and the total current of the given network. That is step number 2. And step number 3 is, we have to find out, or we have to verify the V by I ratio. That is step number 3. Suppose let us say, so I am taking the previous example only. So for example, here, so plus minus voltage is V, resistor is R1 and resistor is R2 and resistor is R3. For example, in previously here we are taking the current value. So now I am taking the current here. Let us take current as I1. So now we have to verify the reciprocity theorem. So how we can verify the reciprocity theorem? So in that case, so first of all we need to calculate the total resistor. After that, current through R3 resistor. After that, we have to find out the voltage and current ratios. Okay, we'll get V by I1. This is for the case 1. And second case, in case 2, now we have to interchange the source to the current side, means this side. So in that case, so we have to redraw the new circuit here. So now source is here. So plus minus, voltage is V, the resistor is R1 and this is resistor is R2 and resistor is R3. Now here we need to calculate the current value, that is I2. Now in second case also we need to calculate the total resistance and total current. Let us take as I. After that, we have to calculate the current through R1 resistor, that is I2. Now we have to find out the voltage and current ratios, that is V divided by I2. So V divided by I2. Here V divided by I2 and first case V divided by I1. So these two are same, means the reciprocity theorem is verified. If does not same, means the reciprocity theorem is not verified. So here in that case, compulsory we have to get V1 by I1 is equal to V by I1. V by I1 equal to V divided by I2. So we have to get like this. So both the answers will be same in case 1 and case 2. Then only the reciprocity theorem is verified. Okay. So here, for example, we'll go for the one problem here. So here the problem is, so we have to verify reciprocity theorem by using the given circuit. Okay. So in that case, we are having the 10 volt voltage source is there and the 2 ohm resistor, 4 ohm, 6 ohm and 2 ohm resistor is there. Okay. So in that case, so we'll go for the case 1. So we'll go for the case 1. So here I am taking current as I. So current through 2 ohm I am taking as I. Now we are having the source, that is 10 volt and the resistors 2 ohm, 4 ohm, 6 ohm and 2 ohm, right? So in this case we have to use the Kirchhoff laws, nodal analysis, mesh analysis. Okay, like these methods we have to use in this reciprocity theorem. So here, for the simplification, I will go for the nodal analysis. Okay. So here, node is nothing but the 3 elements are connected at single point. We can call it as a node. So here, 2 ohm element is there, 4 ohm element is there and 6 ohm element is there. So these three elements are connected at single point. This point we can call it as a node. So this node voltage I am taking as V. The node voltage I am taking as V here, right? Now simplify the equation or apply nodal analysis here. So here we'll get this is plus and this is minus. So now, so here V minus 10 divided by 2 plus V minus 0 divided by 6 plus V minus 0 divided by, so 4 and 2 are in series, means 4 plus 2, that is equal to, there is no current source, that should be equal to 0. Okay. So now, so here V into 1 by 2 plus 1 by 2, I am taking V as a common here. So V into 1 by 2 plus 1 by 6 plus, and 1 divided by 4 plus 2 is 6. That is equal to, so here minus 10 by 2 is there, minus 0 by 6 is there, minus 0 by 2 is there. So that is equal to, we'll get 10 divided by 2. Now by simplifying 1 by 2 plus 1 by 6 plus 1 by 6, so here we'll get, so let us take this V1, this is also V1, here also V1 and this is also V1. So here by simplifying 1 by 2 plus 1 by 6 plus 1 by 6, so here we'll get V1 into 0.833, that is equal to, so 10 by 2, that is equal to 5. So after that V1 equal to, so 5 divided by 0.833, so here we'll get 6.002 volts. This is the node voltage V1. So V1 is equal to 6.002 volts. Here now, in case 1, we need to calculate the I value, or let us take as this is I1. Now we need to calculate the I1 value. So where I1 is equal to, so I1 equal to, so we get V1 minus 0 divided by, so 4 plus 2, that is equal to, what is V1? 6.002 divided by 4 plus 2 is 6, that is equal to, so here we'll get 1 amperes I1 value. So I1 is equal to 1 ampere. Now we have to find out the ratios, voltage and current ratio. So that is V by I1, that equal to, what is V? 10. What is I1? 1. That is equal to 10. This is for the case 1. So in case 1, V by voltage and current ratio, V by I1 is equal to 10 by 1, that is equal to 10. Okay. So now in second case, in case 2, we have to interchange the source to the secondary side. Okay. So now we have to shift this voltage source to the 2 ohm resistor side. So here we are having the circuit. Here short circuited, and we are having the 2 ohm and sources here, and this side we need to calculate the current. Here I am current taking as a I2. So in previously, in previous case we are taking current as I2. Previously we are taking current as I1. Now we are taking current as I2. Okay. Now the elements are, this is 2 ohm and this is 4 ohm, and this is 6 ohm, and now this is 2 ohm, and the voltage source plus minus voltage is 10 volt. So now we are having the voltage that is 10 volt, right? So in this case also I am going for the nodal analysis. So here also we are having a single node. So here is the one node only. So that node I am taking as V2. Now apply nodal analysis here. So we'll get, so V2 minus 0 by 2 plus V2 minus 0 by 6 plus V2 minus 10 divided by 4 plus 2, that is equal to, there is no current source, that should be equal to 0. Okay. So V2 minus 0 by 2 plus V2 minus 0 by 6 plus V2 minus 10 divided by 4 plus 2, that should be equal to 0. Now simplify the equation. So V2 into 1 by 2 plus 1 by 6 plus 1 by 6, that is equal to, again minus 0 by 2 is there, minus 0 by 6 is there, minus 10 by 2 is there, that should be equal to 10 divided by 2. Now by solving the equation, 1 by 2 plus 1 by 6 plus 1 by 6 will get V2 into 0.833 equal to 5. Then V2 is equal to, here also will get the same thing, 6.002 volts, right? So now we are having the node voltage. Now we need to calculate the current value, means current through 2 ohm resistor. So here current through 2 ohm resistor is I2 equal to V2 minus 0 divided by 2, that is equal to, so here I2 value is, so here we are having the I2 value, so 4 plus 2, okay, this is 10 divided by 6, so 10 by 10 divided by 6 means we'll get, so 10 by 6, so 10 by 6 means we'll get 1.66. So now V2 will get, so here 2, so V2 value is equal to 2 volts. Now I2 value, so I2 current through 2 ohm is equal to V2 minus 0 by 2, so V2 minus 0 by 2 is nothing but 2 minus 0 by 2, that is equal to 2 by 2, that is equal to 1 amperes. Now we have to find out the ratios, voltage and current ratios, that is V divided by I2. So what is V? 10. What is I2 value? 1, that is equal to 10. So now you can see here, in case 1, V divided by I1 is equal to 10. In case 2, V by I2 is equal to 10. So both the answers are same. Then we can say, hence the reciprocity theorem. The reciprocity theorem is verified. So we have to do the calculations like this. Okay. So thank you one and all.